My name is Chuck Alonge. I'm the Manager of Demand Forecasting and Analysis here at the NYISO. My team forecasts energy consumption or demand out from 5 minutes ahead to 7 days and out to 30 years. Demand forecasting plays a key role in the planning and the operation of the power systems. Also, being able to accurately predict demand helps us run effective energy markets here at the NYISO. Right now, the New York system is a summer peaking system. That is, our highest energy usage patterns occur in the warmest months of the year. We will be looking, as more space heating technologies in particular move from gas and oil to electric, that energy use provided by the gas and the oil is now going to move into the electric sector. And that's going to push our coldest months of the year to be reflective of our highest energy use periods. And our peaks, that is the maximum energy use at any one point, could move from the summer to the winter accordingly. For both long-term and short-term forecasting, it's very important for us to determine the amount of energy that's being consumed and also the amount of energy that's needed for emergency situations. For short-term forecasting, that is 5 minutes to 1 week ahead, we certainly look at the weather. We look at weather variables that help us predict what the energy demand is going to be. So for example, temperature, it's warm outside. We also look at humidity, how muggy it is outside, wind speed, and also the amount of cloud cover. All of those things impact energy use. For long-term demand forecasting, we actually can't predict the weather out through next July 2022, for example. So what we do when we're using weather in that constants is we take a look at what is a typical year going to do for weather-wise, and then we look at how that impacts the demand. So what we'll do is we'll take that typical year, we'll take a look at how the weather's been trending over the past decade or two, and then compare that with some of the climate modeling simulations that are out there, look at some of that data, corroborate those results, and use that to trend out what that typical weather profile is going to do over the next 10, 20 years. Long-term forecasting must also consider economic and demographic shifts across the control area. So for example, as the economy continues to improve or the economy enters a stagnant period, the amount of energy use will either pick up or decline respectively. So think of it as businesses are going to be engaging in more activity, using more resources under a healthy economy, and less resources or flat under a more stagnant economy. Also, the proliferation of behind-the-meter generation is certainly something for us to consider. As folks elect to put more solar panels on their homes, and as more businesses elect to do so, maybe out in some extra space that they have or on their roofs as well, that's certainly something that we need to continue to factor into our forecasts. And also as communities elect to build small solar farms to help power a collective of homes, those installations are things that we want to continue to model and examine as they are also important to the forecast. And as communities continue to make choices on appliances, another one that comes to mind is a move to electric vehicles. As folks move to electric vehicles, that certainly changes their residential, and as businesses maybe change their delivery fleets and school districts change their buses out to electric buses, those are going to have impacts on energy use across the system.